Thank you. Appreciate that, Mike. Again, my name is Rob. This is Jesus. We both are cloud architects for Microsoft, and we're going to be talking to you about building scalable systems and kind of the marriage between Service Fabric, which is our next generation PaaS infrastructure, and Cassandra. And so I think the interesting thing that comes about when you start thinking about building scalable systems is that scalability, linear scalability, isn't necessarily the only challenge you're going to come up with. You're going to start to see a series of questions getting raised, and that's because the challenge is that we're running these massive clusters on data centers where we don't have physical control of the hardware. We've got these clusters running out there, and our services are running on servers that are on commodity hardware. So the servers are going to fail. Our data is sitting on servers that are going to fail. And we have to be able to deal with all of those eventualities. And so these questions come about, and you can kind of bucket them into one of two areas, either kind of application-focused or data-focused. And from the application side, some questions are, how do I know if my VM's running? How do I know if my application's running? And if my service isn't running, where do I move it? Do I have any nodes out there with capacity to run those on? Do I have any nodes that meet the constraints that my service needs to run on? How do I move it over there? What happens when I'm running on something that's too hot? When do I move it? Do I have anything I can move it to? From the data side, the questions come about saying, how do I deal with linear scalability? How do I make sure that in the eventuality that perhaps a national disaster comes up and a data center goes down, I want my application to still have access to my data. How do I handle all of those things? Well, that's what we're going to be talking about today. How do we answer those questions?
So if we kind of boil down everything of what Rob just said, we actually ended up with more or less 5 problem domains that we need to keep an eye when we're trying to deal with a situation of building a system that is highly scalable, right? First of all, we need to keep in mind that as we scale, we need to do it with ease and fast. It's extremely important that we take that into consideration. Along the same lines, we need to consider that whenever we are scaling, we need to make sure that we maximize the resources where our application is running. Think about a system that has a large amount of nodes, a large amount of computer resources. You want to make sure that every single resource that you're using in the service or your data, right, is utilized, because otherwise you are wasting resources, which you don't want. Also brings another set of problems, having massive systems brings another set of problems that you need to take in consideration. For instance, how do you maintain the system over time? Maybe you have to rethink the way you actually version and manage updates of your application. So today we're going to show you how you can do that using the next iteration of a platform as a service offering in Azure in conjunction with DataStax. Last but not least, we need to assume that failure is going to occur, right? So embedded in our system, we need to come up with architectures and constructs that anticipate that scenario so we can maintain the availability of our system no matter what. And we're going to talk about how we can do that, some of the innovation that has incorporated in Azure in order to make that happen.
So we kind of raised all these questions and saying, here are challenges that we have. Now we need to start looking at how do we solve those. And so I guess the big question for us is, how does Microsoft solve those? We've got a series of services that we run at scale on commodity hardware inside of our data centers. We have SQL Azure, which is running millions of databases. We've got a NoSQL offering out there, DocumentDB. We've got Cortana. We've got a host of other systems that are running out there at scale. So how do we manage all of these challenges? Well, the answer has been that over the years, we built the infrastructure to do that. We found that you can't just throw more people at it. The problems are too vast. It becomes too complex when you have these massive systems running at scale. So that infrastructure we have is called the Azure Service Fabric. You might have heard it referred to as our next generation of PaaS or PaaS v2, but it's called Service Fabric. And an interesting thing to note is the Service Fabric that we're packaging up out there for people to build applications on is not a watered-down version. It's not a scaled-back version. It's not a light version of what we're using. It's the exact same code base we're running all of our services, or not all of our services, but those services I mentioned, it's the exact same infrastructure. All we're doing is packaging it up to make it easier to use for general purpose. And so that's what we're going to be chatting to you about today. And here's a list of 200 some odd customers that are running this in private preview right now out in the wild. I think the most interesting kind of thing to glean from this slide is that modern architectural patterns. It's the third point I have down there. If you talk about cloud architectural patterns, it won't be too long until you start hearing about microservices. And if you're not familiar with what microservices are, think about, as opposed to taking a big monolithic application with a big monolithic database and deploying that, as opposed to doing that, microservices, basically, that approach tells you to take your system and break it down into smaller pieces, break it down into smaller services. If you're familiar with domain-driven design, microservices kind of map to bounded contexts. So you take your system, you break it down into a bunch of smaller services. And this yields many results, many of which we're going to be talking about today. The interesting thing about if you break your system down into a bunch of services, each one of them independent, that can be managed independently, deployed independently, and versioned independently, is that you get many benefits, not the least of which is maintainability. But each of these services is wholly owned. They own everything, including their data, which gives you some additional capabilities. You can use a different back end for different services. So for instance, let's say I had one service that was search-oriented. Maybe I want to use Lucene in order to meet the needs for that search. Maybe I have another service which needs massive scalability. I need to be able to handle massive concurrent writes. I need to be able to handle cross-data center replication. Well, that's a perfect spot for Cassandra, which has established itself as the leader in that category. So as we start talking about building massively scalable systems, the marriage between Cassandra and Azure Service Fabric makes a lot of sense.
So how many of you guys know that you can run Linux on Azure? All right, so less than half of the people. So Linux is a first-class citizen on Azure, right? So all the open source solutions that you're familiar with that you typically think that wouldn't run the Microsoft platform, actually they do. And one particular example of that is DataStax and Cassandra. We actually have two mechanisms to deploy DataStax and Cassandra on Azure. One is through our marketplace. It's a growing ecosystem of Azure-certified solutions that are ready to go, that you can instantiate whenever you need to, right? And these solutions consist of open source solutions as well as enterprise solutions. In addition to that, we recently enabled a new technology where you can declaratively specify the resources that you want to deploy into Azure. Right? So instead of programming a sequence of scripts and a sequence of events, right, you can declaratively specify what your solution is going to look like. And through that mechanism, we have the ability to deploy Cassandra as well. So let me show you a quick demo of that. So what we're going to be doing here is we're going to go into the marketplace. We're going to look for DataStax. There are 3 instances that pop up. One for production scenario has been certified. Another one that is for test scenarios, and one that is for developer purposes. So we're going to instantiate an instance of the DataStax for development scenarios. So what we need to provide is very simple. We just need to provide the name of our VM. In this case, it's going to be dev. Yeah, so as you can see, this is a video, so I don't have telepathic powers, So it's a video that we recorded earlier. And you provide the username, the password. If you want to use the SSH key, you can do that too. And then we need to provide the resource group. The resource group is a construct that we use for management purposes. We just need to specify the location, the region where you want the instance to run. We select the size of our instance, how big that is. And then we're good to go. There's some additional configurations that you might want to tune in, but for the most part, for testing and prototyping purposes, you're going to be OK with the default values. We say OK, and then we click Buy, and then it will go ahead and instantiate our instance. So what I'm going to show you next, so this is the marketplace offering. As you can see, so few steps, you get going with a Cassandra instance in a single node. But what about if we want to deploy a full cluster? Well, for that, we use the templates. The templates are hosted in GitHub, so we have a very strong relationship with GitHub in the way we deploy things from GitHub. We have that button over there. That basically what it does, it will try to deploy our JSON template to Azure. And then what is going to happen here is that we're going to, after getting authenticated, we're going to get to a point where we need to provide the information to deploy our Cassandra cluster. So we select the region, the name of the storage account, where physically the BHDs are going to reside, the DNS name. This is the name that is going to be used for the name of instance of Ops Center. Name of the network, again, the username and password for our instances, the Ops Center admin account, the password. We want to select also the size of the VM that we want to use for all the nodes, and then the number of nodes that we want to deploy. It's very important. So you can deploy as many as you need. You accept the terms, select the resource group, or create a new one if you want to. In this case, we're creating a new one. And that's it. So in the meantime, what is going to happen after this template is deployed, Azure is going to try to find opportunities to parallelize the process of deployment. So we're talking about 3 nodes in this particular case because it's Ops Center plus the 2 Cassandra nodes. It's going to try to do it in parallel. It's going to take a few minutes. But in the meantime, let me show you something that already is in place that is running, so you can understand the end user experience after the deploy is successful. You ended up with an instance of Ops Center up and running, where you can just log in with the password that you specified early when you set up the template. You can log in, and then this is a familiar screen for you guys. We can just click on it, create a brand new cluster. Since we deploy 2 nodes, I can just provide, I'm going to do it in a second. We're going to provide, after we provide the username and passwords for connecting to the DataStax repository, we're going to enter the IP addresses of the nodes, and then we're going to be good to go. So let it go a little bit. I was faster than the demo. Specify that. The IP addresses of our nodes right here. So again, we deploy 2, so I'm going to enter 2 instances of this based on the private IP addresses. And then once you deploy them, what is really cool about this is that all the best practices are already in place for redundancy in terms of a local data center. But in addition, you can extend that configuration so you can deploy another instance of this across another region, and then you can create a VPN connection between the 2 instances, and then you have now a geo-replicated Cassandra cluster. So we talk about how Rob and I talk about scalability challenges. We talked about how you can deploy Cassandra. We talked about the scenario of deploying Cassandra to the cloud. But let's talk about now another specific challenge that is very important to understand, right? So what happens when you have a massive amount of nodes, right, and you wanted to do something that is very cost effective? So the Data Fabric introduces an interesting concept that is very important to understand so you can maximize the return of investment. So the Service Fabric, from the perspective of the Service Fabric, the idea of a cluster is independent of the hosting VMs where the cluster will be deployed. So you can have a cluster that is running on a local machine, right? One single machine, multiple nodes, right? Or you can have a cluster that actually runs across several machines. Right? So that layer of abstraction actually provides very powerful scenarios for you. So let me explain one of those scenarios in contrast with when you don't have that. So let's take, for instance, a scenario where you are typically considering one VM to a node in the system, right, in a cluster. Well, that creates a few challenges. First of all, chances are that that node that you have, that single computer that you're using, you are not using it all the time the most efficient way. There are going to be low times. There are going to be scenarios where not all the CPU, RAM, or these resources are going to be fully utilized. So therefore, you're basically leaving money on the table, right? Also has an implication in terms of the scalability and recovery from that scalability or failure, right? Because from that perspective, if you want to increase the number of nodes, you have to wait until the VM is fully loaded so you can deploy your application there, right? Similarly, if something goes down, you have to wait until another one is provisioned, get ready, and then you can provision your application. In contrast with the Service Fabric, because there is that layer of abstraction between your cluster and infrastructure, you can achieve what is called in the industry a high-density scenarios, where you can deploy multiple services that are independent of each other within a single VM, right? In addition, the Service Fabric has the capability to manage the amount of resources so that you don't overtax or overutilize those VMs. The other benefit is that in the case of auto scalability, because there is that decoupling of the underlying infrastructure, you can create those instances and deploy those instances of application way faster than before. And the same recovery, from a recovery perspective, the orchestrator is going to take those instances in case of failure of a node and try to deploy very fast to another existing node or instance. So, because we don't know, we don't control the underlying infrastructure, how can I manage the way I deploy the information, or how do I deploy my instance, how do I deploy my application, and how do I control where does it go? Well, the Service Fabric introduces the concept of placement constraints, where basically you specified the type of node, right? And based on that type of node or metadata that you assign to a node, you can control what part of your application goes where. So in this particular example, let's assume that we have a very simple application where we want to expose the web part to the outside, that is outside the DMC, and another internal part of our application that we want to expose internally to an internal network. So by defining a set of metadata in our nodes, we can control what part of the application goes where. So we have full control of even though we don't have control of the underlying infrastructure, we have full control on how our application is deployed and controlled and deployed in Azure Service Fabric.
This is going to be a little challenging with holding the mic. So, no, that's just creepy. So what we're going to do now is we're going to show you, we built a demo application. And we built the application to help illustrate some of the challenges that you have and how the Service Fabric helps you to deal with those. And so this is a typical shopping application. And so I think it's important to note, if you look up at the URI up here, it's running on localhost. So this isn't deployed out in the cloud yet. It's not deployed in Azure. It's not in Service Fabric. So this is a local instance running. It's running on local data, all sitting in memory, okay? But I wanted you to see what the application did before we deployed anything. So we can go ahead and do a search, and we can search on just in general anything and get a product and add it into our shopping cart, and we've got a cart out here, and then we've got a frequently bought, or people who bought these might also buy these. It's a recommender engine. And the interesting thing when you start to look at this application is try not to think of it as one giant whole, but rather a set of microservices. So over here, here's my search microservice. And as I mentioned earlier when I was describing it, the backend for that may well be some kind of indexing engine like Lucene or Azure Search or something like that. Over here, I've got top sellers. That may be running in any variety of NoSQL systems. But when you start to look at the cart, and I start to look at the problem domain for a shopping cart, this is where I need that massive scalability. If I've got millions of concurrent users out there buying my wares, and they're all constantly updating their cart, I'm going to have a massive amount of concurrent writes. I need this linear scalability, and I need to make sure people don't lose their shopping cart in the event of a data center going down. So the back end for this microservice, we've chosen to use Cassandra because it's perfect for all of those challenges that I just mentioned. So we've got Cassandra sitting behind this microservice. So for what we want to do in this demo is, I basically, instead of clouding the issue and making it very complex, what I'm going to do is just that one microservice. That's what I'm going to deploy out into the Service Fabric so we can very clearly see how the deployment works, how upgrades work, et cetera. The rest of them I'm going to leave stubbed, okay? So let's minimize that. And what I want to do is I want to show you, first of all, the cluster that's running out in, the cluster that's sitting out in Azure. So this is actually the physical VMs I'm going to be showing you here. So I've got a resource group, and as Jesus kind of mentioned earlier, resource groups are just kind of a logical grouping of physical assets, physical hardware. So I've got this resource group that I called Bagby SF Cluster, Service Fabric Cluster, and you can see all of the physical hardware out here. I've got 5 VMs in my cluster. I've got a load balancer sitting in front of those. I've got my NIC cards, and and they're all sitting inside of a virtual network. So I've got all of this hardware that's out there. Now, the key to what we're talking about is we don't want to basically say, hey, when I deploy this service, I want it to go out onto this specific node. We want an abstraction in there, or a separation between the two. And that's where the Service Fabric comes into play. So I've got a view into my Service Fabric cluster. So I've got a Service Fabric cluster up here, right here, called Bagby SF Cluster. It's associated with what we just saw, the physical cluster out in Azure. If we take a look at this thing, under one view, which is the application view, you can see I have no applications that have been deployed out there yet. And in the nodes, I don't have any services deployed out here at all yet. What I want to do is I want to go ahead and deploy that one service I was talking to you about. The one service that we had, which is my cart service, which is using Cassandra as its back end. Okay? So let's deploy that. So right here, I'm going to use a script that I've written to do this deployment. Your choices are you can use PowerShell, or we've got a cross-platform CLI that you're able to use to do the deployment. And in just a second here, that script I've basically said, will you deploy my service out across 3 of the 5 nodes in my cluster? I didn't add any placement constraints in there, but I could have. So if we do a refresh here, and I take a look, we can see that now my shopping service has now been deployed as an application. And if I start looking at these nodes, you can see that my application's been deployed across 3 of those nodes, which I asked it to do. Very declarative. I said, deploy across 3 nodes. I don't care which nodes. You take care of it as long as it gets deployed across 3 nodes sitting behind a load balancer. If we go back into our web page, here is a web application that's been deployed out to the same data center that my Service Fabric is in. And as that pops up here in a second, I guess it's got to seat itself up. As he pops up, I'm going to run a quick search here. We're going to grab an item. And that's going to go, now that's getting pushed into that service you just saw me deploy. This is talking to that service that's now deployed out in Service Fabric that I just showed to you. And it's going to take a second because nothing's hit that service yet. And this guy's now sitting out in the cloud. So with that, why don't we just jump back. And again, the purpose of this portion of the demo was to introduce to you what the application is. As we start talking about those problems in more detail, we're going to show you via this application how we start to solve those. Let's go back to our slides.
So I just want to mention something about those demos. Those are live demos, by the way, guys. I mean, you know, we took a lot of risk on making sure that that's the case. That's a Cassandra node, a Cassandra cluster running on Azure. That's a Service Fabric running on Azure. We wanted to show the real stuff. So that's live, right? So, so we took a lot of risk, and so far so good. Knock on wood, it's working, right? So the next point that I want to tell you about is availability. As I mentioned earlier, it's very important that we think of our system as a system that eventually is going to fail. So what do you guys think are the primary reasons why a system failed? You know, at a very high level. Anyone can tell me? You know, so what do you think, Rob? What would be? Hardware failure. What else? You know, what other scenario you think, you know, will come into the mix? For sure, right? That would cause another failure. Software failure. Here you go. That's exactly it. So we need to make our system at least resilient for those 2 scenarios, hardware failure or upgrade failure. So in order to help you with that, Azure introduces 2 constructs that are very important to understand. You know, whatever you're dealing, whether you're doing something with the Service Fabric or any other system or any other aspect of Azure, these 2 concepts are very important to understand. So we have the concept of fault domains. Fault domains, you can think of them as a single unit of hardware that can fail, right? And update domains, meaning it's a single unit of software that can be updated at the same time. So what does it mean? If you have an application that has at least 2 tiers, like the one I'm describing there, the web API, a web and an API tier, right? You need to make sure that the full stack of that application is at least in 2 fault domains. So in the event of a failure, because one domain goes down, because you know typically a domain correlates physically to a rack in the data center. So if one of those goes down, then you have the capability to fail over to the other one. Similarly, for upgrade domains, you need to make sure that you have at least 2 instances of every tier in your application. So when you are changing something in that particular tier, when you're updating a version of that particular tier, then you have control, and then you can fail over to the next one. So I guess it's the birthday of Dwayne today, right? So Next. So how do you use this in the context of the Service Fabric? So let's assume that you have a system, right, of multiple microservices that are deployed across several operating domains, right? And that version of your service is something that is very important to you, right? And you want to operate that, right? So one of the things that are introduced as part of the Service Fabric, and it's important that you think about the implication of doing this, is the concept of rolling updates. You have full control of when something gets updated in the Service Fabric. So for instance, if you want to gradually update a version of your application because you want to see how the system behaves, in a very narrow scenario, which is a technique called in-flight testing, right? Then you can do it. And then you can gradually, using the constructs of update domains, increase the number of instances that get upgraded over time. What's important to consider here is that any particular moment in time, if you want to roll back, the infrastructure has the capability to do that, right? So you gradually upgraded one upgrade domain, didn't work out, your telemetrics said, the behavior that I'm seeing here is not working as expected, you can always roll that back. And that's coming from the infrastructure, that's what gives you the Service Fabric. We're going to show you a demo of that.
But before we do that, we're going to talk just very briefly about maintainability. I don't want to kind of beat this whole microservices thing to death, but when you break your application down into small pieces, into services that can be independently managed, can be independently versioned, and independently deployed, great things happen from a maintainability perspective. Think about the challenge that you have if you're deploying your application as a monolith and you have to make one small change to one small piece. When you deploy the entire application, think about the risk that you've brought upon yourself. By breaking it down and having your services living independently, you greatly minimize the risk. So I just wanted to touch on that just very briefly. The next thing we're going to do is I'm going to show you a demo on two sides. One is handling failures, and the other one is the rolling up, the upgrades that Jesus talked about. So let's just jump back in to our application here. Okay, so let's start with the failures, handling failures. Let's go back out and take a look inside of my view. This is just a view into my cluster, a UI, if you will. Notice I told you I asked to have 3 nodes, my 3 instances of my service running across my 5 nodes. What happens if one of those nodes goes down? I'm going to go ahead and kill this node. I'm going to kill VM2. So I'm just stopping that. The action succeeded, that node goes down. Let's go ahead and just refresh, see what's going on. You can see VM2 is down. If I refresh it again, it's going to turn red. Well, now it's not going to turn red, but it should have turned red. Either way, notice what happened. The Service Fabric automatically noticed that that node was down, and it automatically moved it over onto another VM. You can see it's moved over to VM1. It's not quite green yet because it's not quite active yet, but it has been redeployed over there. So the Service Fabric is in charge of us making sure that the topology that I've requested is being adhered to. And so if a node goes down, it's going to take all of those services and it's going to find the appropriate place for them, make sure that we've got assets that have the appropriate resources for them, and it's going to move them over without me moving a finger. The next thing I want to talk about is the rolling upgrades. So let's take a look at this app out here. Now, I've got a UI out here, and if you look at the price, just to the left of the price, you don't see anything. You just see we've got the name of our book and then the description. But I've got a service out here, my shopping cart service. I've got 2 versions. Version 1 is deployed. Version 1 does not return the year that the book was written. Version 2 does, okay? My UI is tolerant of both versions. So if you supply it with a year, it'll show you the year. If you don't, it won't. So what I want to do is I want to deploy version 2 of this service. I'm going to go ahead and kill this guy. I'm going to remove this guy from my shopping cart just to make things a little bit clearer. That's going to get removed. And what I'm going to do, again, before I do this rolling upgrade, I want you to take a look. You can see down here at the bottom, do you see where I'm highlighting? I've got version 1 of my service and version 1 of my application. Same thing on this instance, version 1 and version 1. The other thing I want you to notice, if you look where I highlighted, look to the very right. Do you see the UD0? That's upgrade domain 0. So this guy's upgrade domain 0, he's on upgrade domain 2, and he's on upgrade domain 4. So when I do this rolling upgrade, what's going to happen is this guy's going to get upgraded first, then this guy, and then this guy. And we're going to be able to visualize that. We're going to be able to watch it as it goes. And the items hitting those services are going to hit either of those services as that upgrade goes forward. So I've got a script here to run my upgrade. So I'm going to run this upgrade. Things are going. Now I'm going to configure this thing to do an auto refresh every 2 seconds. And you'll see on the bottom right a little blip will occur. And let's just watch, and let's just see this shopping service go from 1 to 2. And that should happen in the next 10 seconds or so. This is live, and if it doesn't happen, it's generally Jesus' fault. When it works out well, it's my hard work. And you can see it's gone to 2. Now let's move up to this guy, and you can see he's still at 1. So upgrade domain 0 is at version 2. Upgrade domain, this guy has just moved up to 2. So we're at 2, 2, and, no, he's still at 1, sorry. That's a UI glitch. You'll see this guy will get popped up to 2 in the next 10 seconds or so. Or you can blame Jesus again. He's going to own the problem. Here we go, we're up at 2. And now our last but not least, and he's going to pop up. And here's that awkward silence for that last 10 seconds that I'll fill with just worthless speech, random noise. Not one joke is coming to my mind at this point. Okay, so now we're all at version 2. So let's go back over here into our search. Let's choose a product. Let's add it into the cart. And because we have new services out there that have not been seeded, so as soon as that runs up, we will hopefully see the year show up in our UI, and we'll have seen both how we handled failures as well as how we handled those rolling upgrades. And the only other point to make is, as those upgrades are going across those upgrade domains, the Service Fabric is looking and seeing if it was successful. And if it wasn't, you can configure it to do an auto rollback for you. So it's kind of taking a lot of the pain away from you. Let's jump back to our slides. We're not really jumping, because that would be dangerous. We're going to talk a little bit about scalability now. There are really 2 points I want to make when it comes to scalability here and what you see here. One is that we want a clear, and I've made this point, and Jesus has made this point, but I think it's important to really hammer down. There's a clear separation between my physical infrastructure, my cluster, if you will, and my application. And the second point is, I want a declarative model. I want my application, I want to just declare in my application, here's the topology I want. I want these services running on nodes that look like this. I want these services running on nodes that look like that. These have to run inside of a DMZ. These I want public facing. These need hardware with this kind of storage, et cetera, et cetera. I want to just be declarative, and then I want to hand it over to the Service Fabric and let the Service Fabric deal with placing those nodes on hardware that's running that isn't overburdened. We want it to do the balancing for us. I don't want to be in charge of saying, hey, is my application, this service running slowly? Have I used up all the memory on this box? Maybe I should move this service over to another box. I don't want to do that. I want to tell it. I want to tell the Service Fabric, look, I need this deployed here, and I don't want, in the event that memory exceeds this, move it. I'm overburdened. Okay? Now, all that being said, we need some control. As Jesus talked about the placement constraints, I can't just have my software thrown anywhere. I need to be able to define the type of hardware I want it to run on. I also don't want some infrastructure moving my services and rebalancing randomly. I don't want it to have to determine, hey, when should I rebalance? I need that kind of control. And so we do have that control, and they're called thresholds. So we have both balancing as well as activity thresholds. And so from a balancing threshold, you can think of it this way. You wouldn't want services to be moved from one node to another at every slight imbalance. You want to be able to define saying, hey, when this guy is using up twice as many resources as him or 30% more resources than him, then I want you to rebalance. And that's a balancing threshold. An activity threshold basically tells you, look, I don't need you to start rebalancing if no one's using this thing. If the memory usage is negligible, and maybe I'm out of whack, but it's negligible, I don't want you to rebalance anything until we at least hit this threshold. That's when it's going to start affecting my customers. So that's the type of control we have. Now, the last thing we want to do before we jump into questions is do a very quick demo on scalability. Now, as we start approaching, again, we're still in preview. As we approach GA, which general release, a lot of what you're going to see here is going to be, you're going to be able to configure, again, through policy, saying, hey, when we hit this threshold, automatically scale up a node, add a couple more nodes to the cluster. Right now, I'm just going to kick off a script to illustrate this to you. So again, we have running across 3 of my 4 nodes. I'm going to go ahead and start this node anyways. So I've got across 3 of my 5 nodes, I've got my service running. I'm going to go ahead and just kick off a quick script, which just tells me, hey, I want this to go to 4. I want to go up to 4 instances. So let's run that, and let's take a quick look. This should be fairly quick. Let's see. This is live, not Memorex. And you can see just that simply, I was able to scale this, scale my stateless service now across 4 nodes. And so with that last final demo, I think we have 3 minutes left for questions. So do we have any questions? Thank you, first of all. Yeah, yes, thank you guys very much for coming to the talk. Question over here.
How do you maintain quality of service between 2 services running on the same node so that one service doesn't eat resources of another one?
I'm sorry, I can barely hear you.
How do you maintain quality of services with respect to consumption of resources by a particular service?
Okay, so if I make sure I understand your question, how can we make sure we maintain quality resources to make? Is that a noisy neighbor question?
Exactly.
Okay, so we're deploying to our own cluster. And so that cluster itself, that's our hardware. So there not going to be any noisy neighbors on that. Now, when you're talking about if you yourself, your own service is a noisy neighbor, that has to do with constraints that you can play on. And I kind of alluded to those thresholds, but we can configure into the Service Fabric saying, hey, when this certain, whatever it is, it could be CPU, it could be memory, but you can also define it yourself. It's an open system. When this exceeds this threshold, then we need to balance, and you need to start moving software around so that we're not exceeding that threshold. So it's basically through policy.
Seems like there's a lot of similarity to PCOS. I understand there's templates around PCOS on the server. Can you talk about when you run Service Fabric versus PCOS?
Yeah, so the important consideration is is not only with that offering, there is a bunch of other offerings that do the same thing. What is important is there is a lot of innovation in the area, right? There is a lot of innovation in that level of abstraction where now we're bringing the application higher. So we're not doing a one-to-one comparison. A lot of the capabilities that you find in all the other competitors, we have them here, right? But in addition, we have a programming model, and we're emphasizing developers, right? It's more about having an infrastructure and then separating the development efforts. We're actually trying to integrate both, right? So the core foundation of the Service Fabric is all the orchestration that we talked about, but also a very rich programming model based on the SDK.
There's a couple of things I'll add to that in that you can have a very nice relationship with the Service Fabric between your services. There's a model where you can tie into the health. So I mentioned earlier, how do I know if my VM is running? How do I know if my application's running? My application can report out to the Service Fabric its health, and so I can have that nice relationship. One thing we didn't touch upon here also is a stateful programming model, which is also available in the Service Fabric. And I'll kind of leave that to you to look at, but it's a nice offering, and it's something worthy of taking a look at. And we can chat about it after if you want.
One more question.
One more?
A lot of the scripts that you had up there seem manual. Is there any automated way that you guys have of deploying these services onto the VMs?
Yeah, so some of what you saw, I was running manually through scripts that will be done through policy. And so, like for instance, when we were doing the scaling, you wouldn't do, in the end, when we hit GA, that will be done through policy. And we'll say, as we get to this point, it'll move up and it scale up or scale down, and you can do that through policy. So some of that you wouldn't have seen. Some of the rest of it is, I mean, scripting is the way of DevOps today. And so when you start to talk about doing versioning up, the typical way people want to do that is through scripting. And so that would be pretty much how they would handle that. You would write your scripts, they'd be parameterized. You would say, I'm moving from version X to version Y, and here's my backout strategy, and if it fails, I want to do this. So it's kind of a combination. I feel badly when I'm doing the scale up demo and running a script because no one's going to want to be sitting there. You can almost envision a guy going, should I scale up now or no? And that's not the way it's going to be. That'll be done through policy.
Thank you.
All right. Thanks again, guys.